Okay, so we're working on this thing again. This is our invention here. So we made a new pin, and I don't remember if I recorded anything about making that pin, but we essentially turned and ground a pin, a new Jesus pin for this, and then we built this binding system here where this socket head cap screw pulls from this nut here is drilled out, and then it's got this 3/4 inch plate, and then essentially that binds that pin back, because I think that this design is originally was pretty poor, considering that as soon as this pin was allowed to, or say, you know, wears out any bit, it'll start rocking and rocking and rocking and rocking, and next thing you know, the boom here, which is unreplaceable, is all wallered out. And that's why on my previous couple videos ago, I welded and ground that, or welded and bored out this hole. So we got the new pin made. We made this binding system. Here it is on the other side too. Some grody looking welds, but same deal there. Just binding that pin back like that so that this boom will never waller out again in theory. So that's another piece of mechanical bit, you know. Now this boom doesn't rock. We built, I don't think we're gonna be able to see them, but there's two, yeah, you can see it right there. Two copper thrust washers that we made out of just a real thin copper plate or whatever it was. It doesn't really matter, copper or bronze, but that takes up some of that slack in the in between the stick and the boom, and it provides a wearing surface between the boom and the stick, for the future, so that it doesn't actually wear into the side plate material here or wear into the side plate material here. So that's definitely a lot better, once again, than the original design, because I think Bobcat had a few downfalls. I think some of this stuff in here is kind of poorly designed. So that fixes that problem. And now we're working on this link back here. I've got some pins that I've been making. We just pressed these pins here. This one, this is a greasable one, and then there's another one around here somewhere, but we just pressed those out so then we can cut new ones, because they're all grooved out real bad. Here's the other one, and this is the rig here. So essentially these pins were in here, and then they were welded on the back. If I can get this one back out, just trying to demonstrate. They were welded, they had a big fillet weld on the back, so then I ground them out yesterday. And here is the one pin. This is the non-greasable one. Got the snap ring groove and everything cut in it, but just basic pin. So now today I'm working on this greasable one, and that requires, you know, a great big long hole. This one isn't greasable, but it requires a great big hole to be bored back in here somewheres, and then a relief cut for the grease zerk, and then to cut to length. So that's kind of where I'm working today. I guess I'm going to record my expedition on the lathe as I finish up these pins. Another thing is, we allowed 1/4 inch stick out here so that we have a nice solid surface to weld on, so we can get a great weld on this between this the new pin and the actual plate itself. So these were probably the most wore out. It's really hard to see on video. I mean, you can see it, but it doesn't do it justice. See that? You can kind of see against my hand the ridges in there, but it's not very good. These were probably amongst the most wore out of all the pins in this machine, but we ended up buying enough bar to replace all of these, because while we're in here, we got all new freaking bushings. You might as well just put all new pins in too. So there's only actually these two, and then there's two freestanding pins that we got to get built yet too, and that will also require me to cut. Look, I'm going to cut them out of their brackets. Let me see if I can find one right here. So I'm going to need to cut these ones out and then drill and tap those for grease zerks as well. But so there's 2 of these, and then there's 2 of the others. And that's kind of the next step in the journey of repairing this machine. So I'm gonna get set up and start recording on this pin building. So we'll go from there. Okay. So the first thing is to indicate this part in. Should be pretty close because I did just do another. I did that one last night. So there. So now that's pretty good. So now we gotta figure out what's going on here. I think that's good. There we go. Probably just leave this up, but we're just gonna go for it. Yeah, take it out. Yeah, we'll probably just leave that. It's not really good for your insert. I don't think I could finish. It's not finishing. Probably have it a little slower. Let me get ready. There we go. Finally clean that end up. Go slow. You get a nice finish. You know, we're drilling into that anyways. For the most part, so you don't drill out. Essentially, see, that's what we're making here on the end. We gotta get that relief drill for this zerk, snap ring groove. Then that's the grease hole, so we gotta drill a hole clear back in there for the grease. I get my head away. Okay, so that's good. So I know that I was measuring my previous one that my snapping groove has to be 3/16 from the end of that bar, and that snapping groove has to be 46 thousandths deep. So what I've done is find an Allen wrench. This is kind of funny because it's not the best, one of the correct way to do this. So I've got a custom tool that's been made for that groove that was ground. God knows when, but we had it anyway. So this is how I'm doing this. I take my Allen wrench and I know it's 3/16 Allen, and I line it up. Again, this isn't really mission critical. It's gotta be close. So that's close enough. I guess that's where you can get a very flawed. I almost just made a mistake. See, that Allen wrench is not 3/16 on the points, so you have to make sure that you that you're looking down the flats. So that's definitely a mistake. That's probably not supposed to do that, but you know, there's a lot of things not supposed to do. So now we get the touch. Right there, it's touching. I got pull it, now I'm going 46 thousandths. There. So that should be a 46 thousandths deep groove. We can check that, but probably what I'm going to do is getting the correct snap ring. I'll try to get on video here. There we go. Close enough. I'll go get the snap ring just to make sure that everything's right. I want to make sure for sure that before. I guess I want to make sure everything's right. I'm going to move this camera a little bit because you can see something I can see here is that my wing up there, whatever I call it, is in the way of the shot. So I'll try to find a better spot for this, but I'm not going to leave that garbage. So I'll get the snap ring and try this out. Is getting the correct snap ring. I'll try to get it on video here. There we go. Close enough. I'll go get the snap ring just to make sure that everything's right. We want to make sure for sure that before, we want to make sure everything's right. I'm going to move this camera a little bit because you can see that something I didn't see here is that my little wing nut there, or whatever you want to call it, is in the way of the shot. So I'll try to find a better spot for this, but I'm not going to redo that garbage. So I'll go get this snap ring and we'll try this out. Okay, so I got the snap ring here. Pretty good fit, not too bad. So I didn't go too deep or nothing. So it all works. So now I'm going to chamfer the end of this, center drill it. In fact, I'm going to drill it all right here too, because it's better than drilling that with that bar sticking way out. It's just, the bar is going to be flipping around. So we'll drill that as close to the chuck as possible, and we'll actually be drilling, somewhere into here. And I got a great big long drill selected for the job right here. So, but it's plenty long. So I'll get this camera repositioned and then we'll go from there. Okay, so I'm back. I found that this is an 1/8 inch NPT. So then we go on to our tap drill chart. We go in here, 1/8 27. This says to use a letter Q. So I got another chart that says to use a letter R. So I guess that doesn't really matter. I'm going off the other chart. This is just one that I had that's mobile. So anyways, that says to use a letter Q. So then I go to the drill index. And if you go into the drill indexes, this is one of our lettered indexes. Obviously one that's missing a bunch, but so we go into our letter index. So we find that a Q is 332 thousandths, and this is 339. So we know that. This should be, where did my calipers go? Right there. So this drill here is 3, perfect. Heck, we can probably use this as the tap drill. We probably don't have to drill it out to a letter R. So that should be absolutely perfect. So now that we verified that this is that this drill will suffice for this operation, we need to get it in this chuck. Yeah, this thing's pretty long. So we'll get it in the chuck, chuck it all up. Okay, so now we need to find how far we need to go back in to that pin. So we get our old pin, we find the grease hole. This pin only has a single grease hole right there in the center. And we need to be roughly, you can see, we hammered on it there, so I can't really take a good quality measurement there. We'll just kind of rough it. We need to be about, there's 4 1/4. So we'll go back maybe 4 and not quite 3/4, but somewhere in there, maybe, just past 4 1/4 somewhere, because we need to then drill back into this with the mill. So I'll just start drilling that thing in there, and once I get it kind of close, then I'll start thinking. But until then, no thought required, just drill. This is going to be kind of tough because everything's so far away here. Ooh, see that? Let me move this camera. Move it up into here. really tricky here, right? And then I might do a little zoom. How about that? It's gonna expose me here. So we're gonna see this drill walk like crazy. See that? That's probably really bad. We probably should change this and drill it. Almost looks like that drill is sagging quite a bit there. Ooh, not good. Not good. Hope I didn't just jimmy it up. But it sure sounded like I did, didn't it? I'm kind of a dangerous machinist here. I think we're gonna have to lead this drill a little bit. I've never drilled quite a drill bit this long. Yep, absolutely jimmied this thing. Tough break. I don't think it's gonna focus in, but you can take my word for it. So I'm gonna have to go sharpen this drill back up, and I'm gonna have to lead this off with a slightly smaller but shorter drill. This thing is that's just too unwieldy for starting a hole like that. So I'll go sharpen that drill bit and we'll go from there. Okay, so I just went and sharpened that drill bit up that I just screwed up. So now I'm going to take it, a little bit slower. I've never drilled something with a big long drill like that. So this is a little bit smaller, just a hair smaller actually. But definitely shorter nonetheless. So this should start a lot nicer. I think we can probably dang near getting most of the way with this. So actually, I'm going to kind of set my equipment up. Oh, that's right. So we're going to set up at 1 inch. And we'll just get it close. That should be good now. Okay, we'll get her tight. Now this should be a lot better. Kind of get everything prepped up a little bit with some cutting fluid. Wow, that's still pretty haggard. Huh. Sounds like it's kind of looking like it's wanting to cause some trouble today. Okay, I got a plan. What plan are we on? A, B, C, D, E, F. I got a plan F yet. So let's work on that here. Switch these out. Just drop the chuck key. Here we go. This should be my plan F. There we go. We'll get a little bit better of a center drill on there. I guess probably I should have went with one this big from the start, but you know, hindsight. In hindsight, I guess. So gotta go out quite a ways, but get a little bit better of a center drill in there. Shouldn't hurt nothing. From what I understand, this 41, I think this is 4140, ends up kind of turning a little bit hard. It's definitely a tougher one to machine from what I heard. So I'm just learning. Sometimes you gotta learn the hard way, I guess. Okay. There, now we bogged a pretty good sized center drill hole in there. Whoop. So now we'll try again with our letter R here. Or letter whatever this is. Doesn't even matter, I guess. I don't remember what I just dropped. Now this should be a little better. Oh my, much better. Still bogging pretty hard. Looks like it wants to break that drill right up. Wow, that is just drilling so hard. Oh my God. I don't know what the heck the deal is. It is just going hard. It's probably I'm trying to start with too big of a drill. I'm going to show all my mistakes here. Got nothing to hide. I'm not an expert by any means. Definitely not an expert, but okay, I'm going to go get a little bit smaller of a drill and we're going to try this out. Okay, we're back once again. So now we're on plan A, B, C, D, E, F. Yeah, we're probably on plan Z by now, but we're going to try this smaller drill out. Eventually, I'm going to get this figured out. That last drill was cutting nice. It just was, you could see the drill flutes just twisting. I think this material is real grabby, but I don't. Maybe I gotta speed it up. Now that we're not working on center drilled hole, this is going a lot smoother. Sounds a lot better. I don't know how it sounds on camera, but it's not twisting on that drill so bad. Much, 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 much better. You can hear the sounds of some bad sounds coming from the lathe. She's definitely a little old, but she's got a few hours on her. But one lathe is better than no lathe, so we just make it work. To be honest with you, if you have heavy equipment and you don't have some machinery, I don't know how you can afford to fix this stuff. Heck, this would probably be thousands from Bobcat for the repairs we've done this year. We would be into this for thousands, but all it takes is a little bit of know-how and some want to learn. That's all you need. If I can run this way, the monkey can do it, so. I think we're gonna need to dilute this coolant a little bit. You can see I got a little concentrated. Everything's looking really good here, finally. I'm relieved. Maybe I should have started with the smaller drill from the start. Kind of worked my way up to it a little bit, but I guess you gotta learn somehow. This is cutting pretty darn nice. I'm gonna go in there as deep as I can with this drill. Definitely cleaned out in there. Trying to get it all cooled down. Okay, so my phone died on during the last cut, but long story short, I pretty much bottomed that drill out. So now here is the letter R, which should be pretty close. So now what I'm going to do is I'm going to get it started. So when I take in my my long drill bit, it won't, you know, it's got something to kind of pilot its way into a little bit, be a little bit better on the drill. But anyways, this should be a lot nicer. There, very, very light pressure, and it's just going right in. It's not snagging. Just going in nice. Hopefully my phone is charging, but unfortunately on the camera screen it doesn't show me whether or not it's charging, so I just gotta kind of hope that it's charging. But that's kind of the problem with using a phone then, I guess, isn't it? Yeah. Here, I'll zoom in a little bit, kind of get into the action a little. Very, very light pressure. Probably once again, I'll either bottom this drill out into the hole, whatever comes first. I either bottom it out to where I stopped with a J, or I'll bottom the drill out in the chuck pretty much. So. Very good. Not gonna look. Trying to find on it. Where's the drill? Where the drill stops? I'm gonna keep going because I have a lot more space on that. I'm trying to see if I can get one drill, which will already prove pretty tricky. I hit the sharp of that big one so I can should be sharp as knife. It's really too hot, so. I know the foots are clean, I don't worry about the activation of the chips. I'm going to get that hot. There, really in there. Really in the lane. Looking good. Looking good for sure. Alright, rush. Yeah, definitely looking good. So, we'll do 3 off, and we're going to start playing the next one, so I'll get this out and probably be in there. Okay, we're back. This great big drill. So what I'm going to do is I'm going to get this cranked out to a known value, in my case 1 inch. Set this up. Then I'm going to move the tailstock in until the drill bit looks, you know, pretty close. Maybe I'll just give it a few thwaps with this little hammer. right in there will do. Like I said, I'm probably going to drill it a hair deeper than what it calls for because we don't want to miss it. We don't want to have to be chucking this thing back up and trying again. Rework is the worst, so. This is not really mixing too well. Anyways. Oh, round 2 with the big drill. We'll get everything hosed off real quick. We'll just ease her in. Look at that. Dang near took it to size with that other drill. I hope you can see that kind of weeble wobbling on camera. I don't really know if I can mitigate it. I'm just going to be real careful with it. Ooh. Wow. Look at that. That's why it's tough to drill with this great big frickin' drill. That's why it was probably stupid to attempt it first. It's probably stupid to use a drill bit this long anyways. Really don't sound happy, that's for sure. Yeah, it definitely sounds mad. Do I have this tight? Oh my god. I'm a clown. I don't even have this thing tight. I'll do it. Okay. Now I look like a real idiot.
How deep are you supposed to go?
A long ways. 4 and a little over 4 1/4 inches.
So you're at
1. Now I'm actually drilling. Wow, that looks a lot better. I bet you some of that was that tailstock being loose. Look at that. That's a nice chip. That looks a lot better. This whole drill bit was really wagging. I was like, I don't know what's going on, but it don't look right. But I didn't even think to check this to be loose. I got ahead of myself.
You got it on a 5 1/4, right?
Yeah. So I got a whole another 1 1/4 at least. And I'm going to go a little bit past that. So I'm going to be at...
Do you have the throw?
Oh, this goes way back. I think so. I don't know. I'm going to go until this thing stops. Then I'm going to go some more. That's going to be a long cut. I might just time lapse this. Okay. There we go. 4 1/2. Oop. There we go. Well past where we need to be. Perfect. Now we got to drill that recess for the Zerg. Good enough. Hopefully, since this isn't a chuck drill, it'll be a little bit better. I don't think that the reduced shank drill was the ticket for this job. Probably I shouldn't be cutting this with one cut. I should probably take a medium-sized drill But we're just going for it. That seems to be a common trend with my machining experience. We just go for it. There's people a lot dumber than I am that can do this. There's people a lot smarter than me that can do this. So they can do it, I can do it. This drill bit looks like it has a little bit flatter grind on it too, probably from some special job, considering it is a 19.5 millimeter. And generally we don't do any metric stuff, so this probably was a special job, special drill for a special job that was done in the past years. So it happened to work perfect for us here. But as you can see, it looks like everything's really coming out nice. We got a really nice chip going on. The bit's sharp. It's just going in nice. Definitely a nice smooth cut. It's quiet. It's hot. I need some more coolant here, right? Hose her down. Gotta be careful not to get ahead of myself. Heck, I'll drill this hole all the way through there if I'm not careful. We'll just go a hair past a half an inch. There. There, that's that recess. Now, should have a pretty dang good looking pin. I'll get everything. I'll just check it once with the calipers to make sure that we're in deep enough, but I think we're going to be plenty. Okay, we'll get it unchucked. Oh, jeez, I got that tight. Kind of too tight. There we go. So, this is the end of our bar. Focus up. Yeah, I can't really get any more angle on it, but that's what she looks like. Not very clean yet, but pretty good. So I'll get this cut off and we'll get it all set up. Like, clear this place? Okay, we're gonna put that in slow range. Okay, now we're in low range. Okay, give me the correct size drill.
What size?
I don't know. Just whatever size the original one was. Ta-da! Finished. This is ready to be welded in. Okay, so we started making another pin. Let me grab it right here. So we had to make a new one of these. And I kind of got it figured out now. So initially I was running a little too slow. So if you remember from the shots I took earlier, it was bogging, making some heinous noises when you were hogging into it with that big long drill. There was a lot of vibrations. Well, I sped it up, definitely a lot better. So that's good. And then also I said to center drill I don't know where it is, but if you remember from earlier, I said to center drill the hole. Well, it turns out, since this is pretty hard material, you're just supposed to kind of just touch it, just so that your drill doesn't wander. So, things to keep in mind, I guess. But anyways, now we're down to tapping that MPT grease zerk tap hole in there, and then I'm gonna turn this right off the pin, and then we're gonna weld this onto the new one. So I'll get to tapping that, and I'll show my special lubricant here in a second. Oh, I got this tapping goo on. I gotta get my center on. I forgot about that. Let me. It's pretty gooey. Whoop. Probably don't need all that anyways. But that stuff works wonders. Let me find my live center. Here we are. Now I'm gonna probably have to readjust. Nope. So we definitely want this to be straight. I think I demonstrated this earlier, but we did not have a very good tap earlier, and we also were not using this fancy dancy lubricant. Now, of course, we are doing both of those things. So we ended up having to get a different tap, because that other tap was kind of a piece of crap. And just doing it by hand outside of the, just outside of the lathe, which was all right. That worked just fine. But it's tapping so easy. This is some crazy lubricant. It's super draw, safety draw 722. That's what it's called. But it is definitely a must-have. This stuff is neato. So now I gotta test it, because it is a tapered thread. If I can get my wrench back on. Look at that, spin it right out by hand. Oop, of course. Ugh, that stuff is nasty. So let me get my zerk and we'll test it out. So here we go, got my grease zerk. Need to get my tailstock out of the way. See if it goes in enough that we can call this part of the job done. I think so. We probably could use a few more. We'll give her another couple of spins. Nothing too crazy. Now, since it's already been guided in straight, I don't think we're going to need to get the tailstock in there. Probably we might need a little more lubricant. Or we could just leave it alone. That's probably the best idea. It's probably good enough. But anyways, that's my little, not really secret, I guess. That's just kind of a nice, just a nice little compound there. So now I can get my grease zerk spun in. So for now. And then we can go back to the mill and get that hole drilled out. Actually, I'm probably going to turn this off first. So that won't be too big of a deal here. There. That's what, oh my lord. That's what it all looks like. Looks pretty good. This side doesn't need a chamfer because, as you can see from this pin, this is the welded side. So this side's actually the dud. So we'll have to end up cutting this off and then coming back and then putting the chamfer on, and then after we drill that hole. So now I'm going to get this thing chucked up. I screwed this up big time.